has all the fertilizer and everything in it that's going to be needed to make that corn grow. They have modified that kernel to do that. And they need it to do that so that it can grow quickly, grow big, produce more. For example, a corn stalk, one corn stalk, okay, usually produces 1 to 2 ears of corn. That's it. All right? When you look at the uses of corn, okay, you need it to produce 3 to 4. All right? So they modify it to grow bigger, grow faster, be resistant to certain chemicals, okay, and produce more than what it should. Now, a lot of controversy around GMOs. My personal opinion, for me, neither here nor there, okay? I understand people wanting the non-GMO products, okay? Is there any solid evidence on what happened if they, because people are like, well, you know, it's bad for my child. It's caused my child to have more food allergies, blah, 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 which could be true, okay? Because children now have way more food allergies than they did when you didn't hear of anybody having food allergies when I was growing up. I mean, not even like peanut butter, okay? And look at the people now who can't have peanut butter, can't even be around peanuts, okay? The strawberries, whatever the case might be. I don't know. There's just no solid evidence. Do I have the ability to think for myself? Of course I do, okay? So do I think there could be a connection? Of course I do, okay? But at my age, that's why I say, for me personally, neither here nor there. Because I'm not a child rearing, blah, blah, blah. So if I want my grapes this time of the year, I want my grapes this time of the year. I want my strawberries this time of the year. I want my strawberries this time of the year. So our foodstuffs, sadly, are lacking. They're lacking everything we need, even our meats, okay? Even the foodstuffs that they feed to the animals that will become a meat product. I mean, it's just, so that's why a lot of times we're looking for something different. You know, we're looking for that something that is going to satisfy that craving or meet that need of the body. And our goal is to get these foodstuffs because they are our energy, and that energy comes from the level of the cell. So we need these foodstuffs and take them in. Once again, if you remember, metabolism is the sum of all chemical reactions. So when we take in these foodstuffs, our body, unless it's straight glucose, okay, our body has to break them down. We have to get them into their smallest parts because that is what can make it into the cell. If that makes it into the cell can use it to build something. So we have these processes of the catabolism and anabolism taking place constantly. The way that the body wants to make energy. The way that the body wants to make energy. Use sugars first, lipids second, proteins last. If the body is having to depend on using proteins to make energy, you're in trouble. Something major is wrong. People who might go, for example, on a crash diet may end up getting energy from proteins, and that means their muscles breaking down, and that's not good. In late stages of cancer, because cancer requires so much energy, okay? Cancer, it's the reason that as the cancer progresses in the body, that person begins to lose weight, they begin to get very sickly, to the point where they may be only skin and bones, because that cancer has broken down the proteins of their skeletal muscle. It's basically pulling from all muscle of the body, whether skeletal or smooth, to feed it. And eventually, the body can't take it anymore, and people die from the cancers. So, sugars first, lipids second, proteins last. You really do not want ATP getting done by way of proteins. And the process of producing ATP, we call it oxidation reduction. John?
When you say like proteins last, like when like in like dire situations, if you're going through like gluconeogenesis, like your starting product's lactate. Like what is that?
That's where the body is going to have to pull those amino acids. Okay.
The lactate is that a protein?
Lactate's going to be something that builds up in cells of the body. It's actually a toxic byproduct of energy production, and it's not good to have it built up in the cells.
Right.
So that is something in normal circumstances, the body will detoxify it out of the cells. If it gets to a point that it can't, you're looking at difficulty getting the energy sources, which is not good for the body.
So you say cancer causes people like metabolized protein fats, and that's why they get really thin. So theoretically, if someone could afford to continuously up their diet and eat like maybe 5 times more than a normal person could they put off the effects of the cancer?
Well, your hope is that you get diagnosed and whatever treatment plan you choose gets rid of it or puts it in remission. Now, there will, if it's not, okay, there will be a point during that progression where the person seems like they're eating more, but they're losing weight. But that's only a small part of the entire process of cancer. It's usually more towards the beginning of it, because once that muscle and everything begins to waste away, it goes downhill very quickly. Yeah. So, making ATP, oxidation reduction. What this tells us, somebody's gaining or losing electrons, all right? So we call it a coupling process. Do you know what coupling is? Like in plumbing, pipe work, okay? Like in plumbing, they might use a coupling, basically allowing the two pipes to come together, okay? So it's something that allows the two to come together. So if you remember, because I think I kind of drew this molecule with ATP, if you remember, we have three, because of triphosphate, we have three phosphate groups. The bond between the second and the third is very shaky. That's because if this phosphate is needed for energy, it can break off. We form ADP, diphosphate, 1, 2, okay? This now becomes inorganic, can go anywhere that the cell might need it, provide the energy, come back, attach, and I've got ATP again. So something broke, something coupled. Something broke, something coupled. Does that make sense? All right, we're not getting into the electronic, that's not the word I'm looking for, the electron details of it, okay? I really want you guys to just understand that when that bond breaks, this is inorganic, and that supplies the energy. We go from ATP to ADP, and when it does that, we provided energy to something in the cell.
So you're saying when you break that ATP bond, that's anabolism? Wouldn't that be catabolism?
Now, when the production, energy released during the catabolism, okay, so that's our first step. Over here, if I need it for something, okay, that would be my anabolism part.
Where the phosphate group
Where the
breaks
phosphate
off.
group went.
Yeah, alright. Just, I think the diagram was a little confusing from what you were saying.
Okay. Yeah.
It's like, I always think of like anabolism as like building, right? So it would take that third phosphate and create.
Which it does.
Yeah.
It takes that third phosphate and goes to do something. So I had to break it down to get it to go do something. Do you see that now? Like, in other words, to go from this to this, I had to break it down. And when I did, that P that I got went to help do something.
But to go from ADP to ATP, you need to build, which would be anabolism.
Well, they're looking at this as the outside, because see, watch which way the arrow is going. So they're pulling that energy from an outside source. So it's not going from here. Well, they do have that arrow going there, don't they? I'll see if I can find a better ATP-ADP coupling.
Okay.
Okay? But yeah, and then they're right here, they're looking at it as what was that energy source? Did you take in a plate of spaghetti, which would be a starch, which we got to get it broken down and get those individual component parts so that we can get to the mitochondria to make the ATP. If that helps any. Don't get too, but okay. Okay, I'll see if I can find a better model for you. So this. All right. Now, ATP synthesis. I'm going to show some videos because I feel like if